What if you had a second brain that could catch every tiny mistake in your schematic before you even design the PCB? In this video, I'm reviewing a custom ESP32-S3-based IoT Data Logger schematic. But I'm not doing it alone. I have got AI on my side. From relay and RS485 to SD card and sensors, I'm putting this entire design under microscope with the help of AI tools. Let's find out what's the solid and what could be the spark before it ever hit the board. So, let's get started. Alright, so here we have our schematic design. And if you don't know how to design the schematic in KiCad or how to design the PCB layout in KiCad, do not worry about it. On our YouTube channel, you will find various videos about KiCad or about how to design the PCBs. And if you don't have time, you want to learn PCB designing in fast manner, what you can do is you can follow this playlist, How to KiCad. In this playlist, I have explained everything which is required for beginners or intermediates. They can follow this playlist for learning KiCad or designing the PCB. In this complete schematic, basically I differentiated a lot of blocks on the basis of their characteristic or on the basis of their application. So we will start it from the power supply. So here we have our main power supply which will taking the main voltage in, or you can say this is our input voltage from where we are getting the energy for this circuit board. And in this buck converter I have used TPS5430DDA, which is from TI, and it is able to provide sufficient amount of current for this schematic. Alright, so this is pretty simple and I followed the data sheet, and if you want to check it you can check the data sheet of this particular buck converter IC. Alright, so I followed this reference circuit from the data sheet. Alright, what I added extra here, that I have added a 0 ohm resistor. And why so? Because if I want to check the total current consumption from the buck converter, I can place the ammeter here and I can verify the current consumption from the different devices which is available on the board. So for that reason I have used here a 0 ohm resistor, which can also use for isolation as well. Okay, and we have added a test point as well so that you can measure the output voltage of the buck converter. And anyways guys, if you are confusing at any point, what you can do is you can comment below or you can join the community chat of Ampnics over WhatsApp. The link is in the description. Alright, so this is our main power supply. Alright, then we have another power supply which is low dropout output. Okay, so here we are converting the 5-volt output into 3.3 volt, while in this buck converter we are getting 12 volt and we are converting it into 5 volt, and that 5 volt again we are converting into 3.3 volt. Why we need 3.3 volt? Cause our ESP32 required 3.3 volt. For that reason we need to again decrease the voltage. All right, so these two blocks are the main power supply for this whole board. All right, then further we have our programming port, and this port is basically responsible for uploading the program in the microcontroller. And again you can also debug the board using this same port. Here we have used a type C connector for programming, and we have added a ESD diode as well so that we can avoid any transient voltage or surge on the data lines. Then we have our microcontroller section, and this is the main brain of whole project. And basically we have attached all the input and output devices with this microcontroller. All right, and we have also added a addressable LED so that we can use it as a status LED for denoting or reflecting the behavior of our board. Right, then we have built-in LED and buzzer, which this LED can be used as a fault detector, or for debugging purposes you can use this LED. And along with this LED we have added a buzzer as well. So if we want to do some real time output with the help of sound, we can utilize this buzzer. Along with it we have temperature sensor, and for sensing the temperature we have utilized DS18B20Z. This is basically SMD version of one wire temperature sensor. All right, then we have I2C port, which is fixed SDA and SCL, and along with that we have added here test point for the UART peripheral. All right, so this is our simple blocks of built-in LED, buzzer, power supply, temperature sensor, programming port, microcontroller, and again we have two major blocks, which is RTC, SD card, relays, and mounting hole. Again, why it is important to add a RTC or SD card in a data logger? Because if you want to save something in your device, how you will know that it was on or off, or if you want to log the data on particular time, how can you do that? So in terms of hardware, you can use RTC. Although with the help of Internet of Things or in IoT products, you can use NTP as well for denoting the time. But with the help of hardware, you have to use RTC. Alright. Then SD card again for saving the data offline in your device. And we have added relays as well so that we can automate any devices with the help of this. Alright, so I will double click here and I will land up here. So for I2C, I have used DS3231, which is a very popular IC for RTC. And again, I followed the data sheet for designing this schematic. Then we have SD card, and in SD card the schematic is very simple. uh, with the help of slot of SD card, we have added a TVS diode as well so that we can avoid the ESD, or like the voltage protects, like we can get rid of surges or anything which can cause our SD card. All right, then we have RS485 port where we utilized SN75176. All right, so this IC is responsible for communicating, or you can say if we can automate or whatever you want to do with RS port RS485, we can use it. All right, then last, the relay. So we have used two channel relay for this board. All right, so this is pretty much simple schematic, and if you are worrying like from where you can download this schematic, no need to worry about anything. You will get this schematic on our GitHub. Okay, so you can download the schematic from there easily. Okay, so far we have discussed about this schematic in detail. Now we will review this schematic. Reviewing schematic takes time and it is very crucial for hardware development. If you miss anything, your product won't work or your project can fail. So you have to be very careful while reviewing the schematic. And it is not that simple. But in 21st century or nowadays we have AI tools which can definitely make easy our work. So now I will show you how we can use AI tools for reviewing this complete schematic. Alright, so what I will do first, I will export this schematic design. Alright, so I will click here, I will select the format PDF, and you have to just click here, plot all pages, turn, then close. Now you will find the schematic PDF of this project in your main project file. Alright, so I will open my browser, and for reviewing this schematic I'm gonna use ChatGPT and DeepSeek, and with the help of these two AI tools I'm gonna review this schematic design. So what I will do, I will click here on plus icon, and I will click here add photos and files, and I will add the schematic of this project. Alright, so I'll do the same process in DeepSeek as well, and we will also match the difference between the responses of these two AI tools. Although for designing the hardware I typically use ChatGPT and sometimes DeepSeek also, cause sometimes the response of DeepSeek is much better than ChatGPT, and sometimes ChatGPT is much better than DeepSeek. So what you can do in this case, you can use both of them, and can you will get the better and better response from these AI tools, or you can compare it by yourself as well. For that reason, I will demonstrate both of them, how you can use both of them at a time. All right, so now our PDF file is already uploaded here. Okay, now I will paste my prompt here, which is I already written in my notepad, so that I cannot exceed the video too long. Basically, this prompt says that review this ESP32-S3 based data logger schematic in full detail. Okay, I want to check or review this schematic in full detail. Check for the hardware mistakes, power issues, improper GPIO usage, missing protection components, invalid signal connection, level shifting problems, and any good or bad design practices. Suggest improvements block by block, including power, microcontroller, sensors, relays, USB, RTC, SD card, RS485, buzzer switches, and expansion GPIOs. Mention any signal integrity, EMC, safety, or electrical issues if we found be true. All right, so we have mentioned everything whatever we used in this project, and for that reason I have written this detailed prompt in the message box, or can say in this area. All right, so we have written this prompt, and we will just enter, and we will see what is the review or response of ChatGPT on our schematic design. Let's see. And I'll do the same process for DeepSeek as well. In meantime, it will give us the response as well, and we will check it on both of them. And one thing I noticed using these AI tools, that if you give proper prompt, then you can expect better answer from these AI tools. You cannot underestimate the power of AI tools. All right, I guess we got the complete response from the chat GPT, and yes, we will go one by one. Power supply, good. Uses TPS 5430 DDA buck converter for V into 5 volt conversion, robust 3.3 ampere switcher. Okay, proper use of MBR0520 SS34 diode for reverse polarity and flyback protection, clean LDO AP2112K 3.3 volt conversion from 5 volt to 3.3 volt. All right, bulk and bypass capacitors. Okay, so these are the good thing about our power supply. What is missing? Add a TVS diode SMBJ24 on V in. Okay, so basically, what is this? What is this TVS diode? If you want to use it in automotive grade, or like wherever your voltage is very sensible, like you can expect a surge there, so you have to use this. Since we are designing it for residential purpose, it is not considerable, but although it is great suggestion. Okay, so this recommendation is good. Use a ferrite bead MPZ2012 between 5 volt output to buck converter for input for better noise suppression. Okay, so it is saying us to use a ferrite bead on the 5 volt to 3.3 volt LDO input. Okay, so here here it is saying that better to use a ferrite bead, but again this is not compulsory if you want to use it, because designing a hardware is not about only technically correct. You have to also think about the budget of the product. Okay, so if you just start adding one by one component, and you go for a large production, so it will definitely cause a high rate. Okay, cause if it is about $0.1 and you're going to do the production for 1 lakh units, so unfortunately just multiply that $0.1 into 1 lakh unit. So your production cost is going to be high. So you have to take care of everything according to your application. So as of now our application is not that much crucial, so for that reason we can also ignore the ferrite bit. Next, inductor 15 microhenry is okay, but ensure it supports leak peak current of LDO plus relays. Okay, so basically it is saying that whatever the inductors you are using in your project, ensure that the peak current of the LDO and relays, whatever the current required, it should able to provide it. It shouldn't be less than that. Okay, so we can expect 3 ampere current from it, so which is more than sufficient in our complete board. If everything is online, we are not going to exceed more than 2 ampere. All right, consider soft start capacitor for TPS5430 to prevent inrush related brownouts. Okay, so it is basically saying us try to add a capacitor in the input, but if you notice here we have already did it, so I don't think so it's a problem for our power supply. So here this recommendation is good but not compulsory. Okay, so if I write it that I'm gonna use it for residential purpose, so it will give us more detailed. Okay, and it will definitely remove what are the components are not required. Okay, in USB what is good, USB-C connector used as J1 and connect corrected CC pull down resistors 5.1k, ESD protection with USB LC6-2SC6. What is recommendation? Okay, add series termination resistor 22 ohms on the USB data plus and data minus. Okay, most of the time you guys ask this question that why it is necessary to add 22 ohm resistor on the data line. Well, it is not compulsory to use it if you are not sure that your tracks are not fine, and it may be possible that you are not matching the impedance, then your data or line will definitely affect the problem in it. Okay, so if you are sure that your impedance is fine and both the tracks are equal, then no need to use 22 ohm resistor. Okay, in further videos I will explain you about how to design the layout of PCBs using AI tools. Then make sure to subscribe and stay tuned with Ampnics as well. All right, at that time I will explain you about designing the tracks for USBs. Okay, next, which is consider adding a resetable fuse, example 500 milliampere PTC on Vbus line. Okay, this is good suggestion. What we can do is like we can add a PTC or resetable fuse on the Vbus line. This is good suggestion actually. So but I'm not gonna do it cause I will just program this board for one time, and we already know that in USB 2.0 500 milliampere current is more than sufficient. We know we don't need to worry about it because it's not a development board, or we are not going to use it again and again. All right, ensure the USB shield S1 is connected with the chassis ground, not signal ground. All right, so it is saying that whatever the shield ground should be connected to chassis ground, not to the signal ground. Okay, and with the help of 1 mega plus 100 nanofarad. Okay, so this is a third recommendation for USB. So these points are also good. As you can see, like the recommendations are quite good, like we can follow it as well. Okay, in ESP32 module is correctly connected, input and boot circuits are standard, IO assignments are organized, labeled with purpose. Okay, what are the recommendation? Place zero point 0.1 microfarad decoupling capacitor near power pins of the ESP32-S3 if not already done on the PCB. Okay. So if you maybe ChatGPT missed to consider these decoupling capacitor, basically it is saying that try to use decoupling capacitor on the power pin of the microcontroller, which we already used here. Anyways, we already used it, so we won't talk about it more about it. Okay. Then we have USB data plus and data minus connected to GPIOs 1314, good for native ESV. Ensure proper routing. Again, the same thing which I told you here, that you have to make sure proper routing and impedance matching. So our MCU section is already good. No need to worry about anything. Okay. Then sensor pull up resistor 4.7K on data line is correct. Sensor is powered by 3.3 volt. Okay. For long cable or outdoor deployment, add a RC, low pass filter and ESD protection. Example PEST 3.3 volt. So basically most of the time people touches the temperature sensor with the hand. For that reason it is saying us that try to use a ESD protection for it, or use a RC low pass filter, so that you can get the accurate temperature data from it. Anyways, we are not going to do it with the hand, so no need to worry about it. Okay. And one more thing guys, if you don't understand any point, what you can do, you just have to copy this sentence and again paste it here and say that explain about it in detail, so that you can know about it in better way. Okay. Then we have RTC, good battery backup included, I2C pull up present, proper decoupling. What is the recommendation for the RTC? If you are using DS323M, not SN, note it doesn't have temperature compensated crystal. Consider using DS3231SN if high accuracy is needed. Okay, well, I need to check my schematic again, and we will check it right now about our schematic. All right. So okay, so we have here DS3231. What ChatGPT is saying us, that if you are using this one, it doesn't have temperature compensated crystal. Consider using DS3231SN, which is highly accuracy is needed. So if you are concerned about high accuracy, try to use DS3231 instead of using 3231M. Well, I designed various projects using this IC as well, and this also works fine. But if you are concerned about high accuracy, yes, you can use DS3231SN. All right, but this is fine for me, and it is very popular IC for RTC. Okay, so as of now you can see like our RTC is also fine. Okay, now for SD card, what is good, voltage is 3.3 volt, correct for TF01A module, CD pin routed, pull up provided on SPI lines. What is the recommendation? Add 33 or 47 series resistor on the SPI lines to reduce the ringing and EMI. Okay, so it is basically saying us to use this resistors to reduce the ringing. Okay, so I won't use it because I have already designed SD card in various data loggers without resistors for the same application. It works fine. But guys, if you notice one thing, that if your target is industry or automotive sector, so you have to take care of EMI and ringing or noise, because these minor mistakes cause a major problem in the product. Better to work before going for the design. All right, so for that reason reviewing PCB is always better. Then consider diode clamping. Again, it is for protecting the SD card or SD card slot from the ESD, which we already used here. Okay, then we have RS485 SN75176AD, good. Correction of RODI, and RE. Termination resistor 120 ohm resistor is present. What is it saying? That add 10K pull down on DE and pull up on RE to keep them shown state if MCU is off. Add a TVS diode array on AB line for surge protection. Add a common mode choke for EMI if needed in industrial setups. Okay, this suggestion is good, and if you see here that it is clearly saying that try to use a TVS diode array on the AB line, because when signal comes on the A and B, it can be have some surges from the output or from the wire which is carrying the data, which is carrying the RS485 data. So for that reason you need to worry about it. It is best practice to use TVS diodes on the data line. Okay, so for me this is not required, but you can see it here. Okay, then we have relay MMBT2222A, a low side driver with base resistor, snubber diode for flyback protection. Okay, what is recommendation? Try add a flyback diode across the relay coil, reverse bias to protect transistor for better. Okay, so this is I don't know why it is saying us about flyback diode protection, but we already used it in the relay circuit. You can see here we have our coil, and along with coil we have used a diode parallel to it. And sometimes like instead of using transistor, what you can do, you can use MOSFETs, because MOSFETs also have a body diode. So what's next? Consider adding optocoupler for electrical isolation is required. Yes, this is very important. Like if you want to make galvanic isolation between the relay and your microcontroller, you can use a optocoupler. Okay, and this is very important for industrial applications. Add a small ceramic capacitor along with the VCC and ground for local decoupling. And this is like this is not important at all. For the very first time I'm getting this response from ChatGPT, which is saying that add a decoupling capacitor for the VCC and ground. And one more thing guys, if you notice in all the points, and if you have designed the hardwares before, that sometimes ChatGPT or AI tools talk about everything in detail. So it is not required every time, because as I said earlier that designing a hardware is not about only technically correct, but you have to also take care of other parameters as well, such as the size, the price, the production time, the component sourcing. So you have to think about everything. So this is like stupid statement from the chat gpt. So again I'm telling you, like whatever so far I observed with this AI tools, that you cannot rely on these tools 100%. You have to use your own brain as well, or you have to use your own experiences as well. Okay, for 9 buzzer driven by MMBT2222A and series resistor. What is the recommendation? If buzzer is inductive, add a flyback diode. If piezo, then okay, but consider a PWM control tone for variability. Okay, this is like not necessary, but if your buzzer is inductive, add a flyback diode. Okay, this is good suggestion. But if you see here, we have used this buzzer, okay, with the help of this transistor. Again, if you want to avoid this flyback effect, what you can do is like you can use a MOSFET instead of using a transistor. Okay, cause MOSFET have a body diode. Okay, but for me this combination works fine for me, so for that reason I'm gonna keep it as it is. Why I'm showing this review? So that you can take a idea about it, how you can utilize these things in your designs. Okay, then for LEDs, status LED D4 D6 etc with current limiting resistor, push buttons, SW1 SW2 connected with the GPIOs with 10K pull downs. Okay, add a debouncing caps 100 nanofarad across the push buttons. Name all the switches. Okay, so basically it is saying us to add a debounce capacitor, which can be used or not used. So if you want to use it, yes you can, but most of the time people use it as it is without using debounce capacitor on the user buttons. So I'm gonna follow the major designs. I won't use this capacitors. Okay, then name all the switches clearly, reset boot and user. So this already button mentioned, I don't think so we need another level for it, but yeah, you can see this is connected with the enable and this is connected with the IO0. We have addressable LED, 0 ohm series resistor, R9 for current limit, uh, but acceptable. 3.3 volt supply recommendation, RS 2812 often expect 3.5 volt logic, so level up shift might be needed for ESP32-S3 3.3 volt. Test if directly works reliably. If not, use a buffer like 74AHCT125 and add a 100 nanofarad capacitor close to WS2812 VDD. Okay, so basically it is saying that most of the time this LED needs 3 point or equal to or more than this, but ESP32 can give us only 3.3 volt. But guys, let me tell you one thing, that sometimes the theory and the practical works different. Theory says something else and practical word works little bit different than theory. So this is already a done experiment by me. I already used it a lot of WS2812 LED with the ESP32. It works fine, so no need to worry about using a buffer or a level shifter for it. But yes, if you want to play on safe side, then you can use it. But sometimes for me, I used to take risk in designing the hardware. If you're not a risk taker, or like if you want to use it, yes, you can use it, but ultimately it will increase the costing of your product. Okay, then GPIO expansion and connector. So we have used IO45 and IO46, leveled and dedicated for future expansion, clear leveling for IO pins. Okay, again it is saying as use the ESD protection diode on the IO pins and add a 100 ohm resistor on the all exposed GPIO to limit the current into unpowered ICs. Okay, okay. So mainly we have all the main important blocks of our schematic, and we have covered ultimately everything. But if you notice one thing, that it has given the recommendation for every block, not even a single block, it left a single block. Okay, so what is said about signal integrity and EMC and safety. Power and grounding filter is adequate. ESD EMI protection added at key points. Okay, what is the recommendation? Ensure short, and most of the thing this is about layout designing, so you can read it. What I can do, I will share this chat link in the description. You can read it by yourself as well. So this was the response of ChatGPT on reviewing our schematic. Although reviewing a PCB or reviewing a schematic takes time, but with the help of ChatGPT or AI tools you can reduce that time very efficiently. Okay, let's check the DeepSeek's response. And this time I want to go in detail. I'll just read it, and you'll match the things with it. Okay, so what's the block by block analysis, power supply, and etc. What is the issue? 680 microfarad seems excessive for the most application. It may cause inrush current. No input reverse protection on the power input. Okay, which is not true. We already used a diode SS34 for it, and why it is saying like this, I don't know. Then again, see, 680 microfarad capacitor is excessive. While in ChatGPT it was saying that use a bigger number of capacitors so that you can flow the current smoothly, while here it is saying that 680, maybe it is following the exact data sheet, cause in data sheet it is different. but sometimes you need to use the capacitor more than the given value, especially in terms of electrolytic capacitors, because these are the secondary energy source after your battery or power supply in your circuit. Okay, no TVS diode on the input line. Again, I won't repeat it. Output capacitor 3.3 volt, which is like C1020. Again, it is saying that it is oversized. Maybe it is following the data sheet again. Okay, no bulk capacitance near ESP32-S3 power pins, which is not true. I already shown you guys that we can find here the decoupling capacitor for this controller. Okay, so in power supply we have no issue. ESP32-S3 section. What are the issues? No series resistor on the data plus and data minus. Again, the same thing which I explained you over the response of ChatGPT. 22 ohm resistor in series. Why it is required? If impedance is not properly matched, or you are concerned about EMI or EMC issues. So if you do it properly, you can avoid it, but if your traces are too long, then better use to 22 ohm resistor. Okay, no ESD protection on the USB line. Well, it's not like that. We already used a TVS diode for USB. No external reset circuit relying solely on internal reset. Well, I don't think so it is required, but yeah. And IO0 N lines have no pull up and pull down resistor for proper boot mode selection. Well, it's not like that. We already used pull up resistor here. You can see on IO0 and enable. I guess DeepSeek is missing this point, or it cannot catch it properly, maybe, but this is not true. No current limit resistor on the built-in LED. Again, we have used the current limiting resistor on built-in LED. See, we have used 1 kilo ohm resistor. So as you can see, like right now DeepSeek is giving some wrong information as well. So what are the issues in USB interface? USB shield not properly grounded, should be connected through 1 mega ohm and 100 picofarad network. Okay, no CC pull down resistor. Again, it's not true. We already added it. USB LC6 to SC6 is placed but not properly connected on the USB lines. Okay, ensure the proper connection of this. I don't think so. We already did it correctly, and we already connected the 5.1k pull down resistor, but I don't know. Maybe this the response of DeepSeek is already wrong. It's not correct. Okay, for temperature sensor, only one pull up resistor is shown in the figure. Should verify this is sufficient for the bus length, and no ESD protection on the sensor line. Well, for the temperature sensor, most of the time people use the TVS diode on the data line, cause if you touch it properly, most the body voltage is about 15 kilovolt. So for that reason, some hardware developers prefer to use a TVS diode on the data bus line. So since we are going to use it for residential application, it is not required. Okay, then we have relay, and again it is telling us that there's no flyback diode. It's not like that. We already use it. No indication relay coil voltage current requirement. Yeah, this is true, and this is what we can do. Like we can mention it there, how much current we can switch from this relays. And you can also find this data over the relays as well, like your relay can drive how much current, or what is the possible range of switching the devices through the relay. Okay, so this is valuable insight from the DeepSeek. Base resistor value 10k may be too high for the sufficient drive current. Okay, so here in this circuit it is saying that base resistor this 10k is very high. Well, it's not like that. It is a basically pull down resistor. It's not a signal, like it is not current limiting resistor. Current limiting resistor is this one, 1 kilo ohm. So this is not correct. Okay, and what are the other stuffs here? IO and expansion. So in this basically the issues are like it is saying us to use ESD protection on the IO pins which we are keeping it for future use or for adding any external sensor later on the circuit. So it's better to use ESD diodes on it so that if there will be any surges or transient voltage, it cannot damage or microcontroller because it is directly connected with it. Okay, then what are the signal integrity and EMC? No proper power plane separation via stitching via shown, no ferrite beads on the power line to sensitive analog section, long traces to temperature sensor without impedance control. Well, these points are relatable for layout designing, not for schematic. So the only thing which I can consider here that this ferrite bead, but as of now it is not required because I already told you guys in the chat gpt's response. Okay, what is the missing protection? No over voltage protection on input because it is not required. We are going to provide say a constant voltage on the voltage input point, so for that reason this is not required. No ESD protection on the exposed connector. Okay, wherever it is required we used it and otherwise we ignored it. No current limiting on the power input. Yes, this can be a valuable insight, but as of now like our schematic is already complete and I cannot find any potential issue. Okay, but anyways we will keep the note for the good design practice. What are they? Use proper decoupling capacitor near the ICs which we already used. Clear leveling of the functional block, yes. Use test point for debugging, yes. Separate mounting holes with proper grounding, yes. So we already used all of these things. Okay, and what are the, well it is good actually. Recommended changes: priority high priority, add flyback diode for release which is already present. ESD protection on the USB and GPIO which is already present. Implement proper USB CC resistor which is already present. Let me show you guys here, otherwise you will say that where it is. So if you see here that we have used this TVS diode for the USB and here in relay section we have used this MBR0520 Schottky diode for flyback protection, so it is not a big deal. And then this pull down resistor, it is also it is also available in our circuit. So you can see here we have used a 5.1 kilo ohm resistor for CC1 and CC2, so it is perfect. Okay, what are the medium priority? Improve power input protection. Okay, we already used a reverse voltage protection. Add a reset circuit, optimize decoupling network. Okay, so we already used the proper decoupling capacitor, but anyways when we design the layout we will look into it again, but as of now no issues at all. What are the low priority? Fine tune pull up and pull down resistor. Add filtering on the analog input. So if suppose you are going to connect any analog input on the extra pin which was on IO 46 and 45, you can use their filtering circuit over it, or on the switches you can use pull up and pull down resistor. So as of now like our schematic is complete and there's no potential issue at all. We already taken care of all the important parameters. So you can witness like in the both response of DeepSeek's response and ChatGPT's response are not quite similar, but yes I can say like there are similarity and I can say 50% similarity, but the response of ChatGPT is much better than DeepSeek, and here DeepSeek is not the game changer. ChatGPT is the real game changer here. So I would always suggest you like whenever you do the review of your schematic, make sure to try it on different platforms so that you can get better response or better understanding of whatever you are doing with it. So guys, this is how we reviewed our schematic, and in next video I will explain you about how to design the layout with the help of AI tools. So this was the video on schematic review using AI tools. Make sure to like the video and subscribe our YouTube channel for more technical content.